So what we're going to do, I don't need this anymore, so I'm going to erase that. Is that okay?
Yeah.
Okay. I'll keep the other stuff because I'll want to refer back to it. So we're going to start with just sine and cosine, and then we'll graph a complicated one, and then you're going to need your calculator because I'm going to show you how to use your calculator to check your answers tonight. Okay? All right, so y equals sine x. Now, I'm going to brag a little bit. I'm really, really good at teaching this. Okay? In fact, you're going to be like, proofs I'm good at, but I just don't know how any better to teach proofs than that. You just got to play around with them. Okay? You just have to. I mean, it's like me and Sam were talking about this Friday. The more you do, the better you get. And I can't really force that on you. You have to make the choice to practice it. How many of you realize that with proofs? Okay, yeah, lots of hands. Okay, you realize that the only way you're going to get better at proofs is just practice it. This, I will get you good after one problem. The only thing you're going to be responsible for is having to memorize how to do these steps. Because my steps are about as crystal clear as they can be, and it will get you there really fast. And the really nice thing is that if you get a really good grasp of what's going on this week, next week's going to be gold. Next week's going to make so much more sense solving equations if you understand this week. If you don't get a good grasp on this week, next week you're going to be so lost when we start having to solve an equation with secant in it. And it gets really complicated, okay? So, I've got some very, very specific things I want you to do here. So first of all, let's go ahead and look at sine x. And let's write some things down. First thing that you'll always want to do is write down what the amplitude is. Now, since we're just looking at generic sine x, we haven't really even changed any of the parameters. Everything's ones. Okay? And there is no horizontal shift and no vertical shift, so those are 0. So right here, A is 1 and B is 1, and there's no horizontal shift and there's no vertical shift yet. We are going to get to one, don't worry. So let's start with amplitude. What is A? 1, and we want absolute value, so just make sure you just ditch the negative when you do amplitude. Remember, amplitude is a distance. It's max minus min divided by 2. Period. Period is what? We already know what it is. Because of the unit circle, what is it? 2 pi. Now, according to this, it's 2 pi divided by b, but b is 1. But in a minute, we're going to change that. For example, if I was to throw a 2 in front of the x, the period would not be 2 pi anymore. I would actually shrink it and cut it in half. There's that horizontal shrinking. You would actually go 2 pi divided by 2, so the period would be pi. And if I put a 1/3 in front of that, it'd divide by 1/3 and it'd be out 6 pi. It takes 6 pi for cosine to repeat. It takes 6 pi radians for it to go through all of its unit circle values. And that's how you can stretch out the unit circle or shrink out the unit circle. All right? So A is 1 and period is 2 pi. Is there any phase shift? Any vertical shift? By the way, that's going to get you 4 points. I'm going to tell you, every graph on my test is going to be 7 points, 6 to 7 points. Sine and cosine will be 6 points. The other 4 will be 7. Here's why the other 4 will be 7. Because here's what you're going to have to do. Amplitude, period, phase shift, vertical shift. There's 4. Amplitude, period, phase shift, vertical shift. When there is no phase shift and vertical shift, you'll just put none. We're not going to do it right now, but on the test, there'll have to be blanks and you'll just put none. You're also going to have to give me domain and range. There's 6. Now there's an extra point for the other 4, because the other 4 have asymptotes. The asymptotes, I'm going to have to teach you how to write those equations, and I've got an awesome way to do it. I'm so glad I don't do it the way I did in high school. I'll show you the way I had to do it in high school. It's terrible, okay? And that's been one of the best things when kids go to college. They say, man, I'm so glad you taught us how to write these equations. I'm so glad you taught us these shortcuts, because it really comes in handy later. And I do it very mathematically based. I'm not teaching shortcuts because it's like a cool way to do it. I'm teaching it based on mathematics. Okay? All right? Not just, oh, I think it does this, and it's some kind of saying that you came up with, because I don't like that. All right, here we go. So what I need to do is teach you how to graph this. All right, so go ahead and draw an XY axis. And I'm going to teach you today what's called the fourth rule. One of the biggest things that I'm going to grade, the last points that you're going to get, so you get 6 or 7 points for that, then you're going to get 3 or 4 points for the graph. And one of the first points that I'm going to give you is on labeling your x and y axis correctly. Now, how many quadrants did sine and cosine have to go through to complete one period? 4. And because it has to go through 4 quadrants to complete one period, we are going to divide up our x-axis into fourths. Now, tangent and cotangent. Does anybody know how long it takes tangent and cotangent to repeat? By the way, hold on. Sine and cosine, it takes 4 quadrants for it to repeat, right? What about its reciprocals? Is reciprocating really do anything? No, it just flips the values. So how long will cosecant and secant take to repeat? Still 4 quadrants, 2 pi radians. But what about tangent and cotangent? 2. It only takes 2. It takes half as much. So the period for tangent and cotangent is not going to be 2 pi. It's going to be what? Pi. And because it only takes 2 quadrants to repeat, when we get to tangent and cotangent on Wednesday, we're actually going to only do halves when we label our x-axis. But for sine, cosine, and their reciprocals, we're going to go to fourths. So here's how you do this. Now, I want you to do it this way. After you get comfortable with it, you can just go and write 4 marks. But what I do is I go out 1 full period. You're always going to be required to graph 2 periods for me. How many periods? You're going to have to graph 2 periods for me. AJ, how many periods? 2 periods. 2 periods. Everybody's going to have to graph. No exception from here to the end. So what you're going to do is 1 period, and then I'll show you how to reflect it. So this is your full period. What is the period? 2 pi. So go ahead and write 2 pi down. Now I need to go to fourths. I'm teaching you basically how to use a tape measure. What's half of 2 pi? So you're going to go exactly halfway, and this is how you'll get your marks in the right spot too. Because if you don't do this, here's what happens to a lot of people. The graphs start looking like this. I can totally see Billy doing this because, colorblind might have a hard time. All right, so his graph will look like this at first, and then it'll go like this, and it'll get big again. I want it to be consistently the same. Okay, I don't want them to be skinny humps and then big humps and then medium humps and then big humps again, okay? All right, I want the humps to all be the same, all right? You with me? All right, so 2 pi pi. What's half of pi? Ready? This is the key. This one is the most important one. This is your quarter mark. This right here, I want you to do something, write something down on your paper, highlight it, exploding candy, whatever. This right here is your count. And here's why it's your count, because that's the last mark I'm going to do, and since the y-axis is 0, 0 to this value is the distance between that mark. Now we divided up all these marks equally, so then this, whatever this distance is, that's going to be the distance between every mark. That is your count. Now we're missing one. In a minute, we're missing the 3/4 mark. Now, here's how you know what this is. I know most of you already know what it is, but in a minute, you're not going to know, because in a minute, the period's going to be like pi over 12, and when the period's pi over 12, you're not going to know what these marks are. Okay? I'm going to know what they are, but you're going to have to figure it out. All right? So you go half of that's pi, half of that's pi over 2. This is your count. So then you can do, like I taught you to count, with pi over 6s and pi over 4s. This is 1 pi over 2. The distance between here and here is pi over 2. Here's another pi over 2. 1 pi over 2, 2 pi over 2 reduces to what? Pi. What would this one be? 3 pi over 2. And then you'll see how you'll do that if that was a pi over 12. Because then you'd say 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. Okay? That count's going to be important, because it's going to be the way to make sure you get your labels right. Otherwise, you're not going to get your labels right, because I am getting a point for the correct labels. Now, once you get one period down, what can you do on the other side? Just negate it. I went into college, and I was a math major, and I had no clue how to graph a trig function. And I am so glad I figured this out, because one of the things I wanted to make sure I taught kids when they got to college is, one, they could flip and do the unit circle, because I didn't know the unit circle in college, and it was frustrating. I wanted to make sure they knew how to graph a trig function, because every time they asked me to graph a trig function, I just look at them like, I don't have a clue. In fact, I didn't really learn how to graph a trig function until my student teaching. Okay, I got around. I mean, that was one of the reasons I didn't get. It's one of the reasons I didn't get an A in one of my calc courses. I didn't have a clue on trig. Trig killed me. Okay, I don't want it to kill you. All right, so here we go. Next step. All right, what we said just a minute ago when we unraveled the unit circle is that these values are the x values. The y values is going to be what you get when you plug the x values into the sine function. So when I plug in 0 radians, I'm going to plug in sine of 0. This x value is the angle in radians. By the way, those are not absolute value, those are ones. So let's make sure we know those are ones. Okay, you can take the ones away if you want. What's the y value? It comes off the unit circle. Where does it come from? It's the y coordinate of your point on the unit circle. It's the sine value. This is the sine value. Sine value off the unit circle. So the x value is the angle in radians. So when I go to 0, plug in 0. What's sine of 0? Quick, quick, quick. What's sine of 0? Oh my Come on, unit circle. Sine of 0. 0. Very good. Let's just go ahead and do cosine to get everybody up to speed. What's cosine of 0? 1. What's sine of 0?
0.
What's cosine of 0? Sine is always going to start at 0. Cosine is always going to start at, say it with me, sine is going to start where?
0.
Cosine is going to start where? Sine is going to start where?
0.
Cosine is going to start where? Cosine is going to start where?
1.
1. Cosine starts at 1. Where does sine start? Where does sine start? Where does cosine start? Sine start? Cosine? Good. Now, if sine starts at 0, you're going to like this. I call this, when it starts, sine starts at 0, which happens to be the middle. Okay? Cosine's going to start at 1, or if you flip it, -1. Sine will always start in the middle. Cosine is always going to start at the top or bottom. See, here's the thing about sine. If you flip it, let's say I put a negative out front. If you flip it, does that change where sine starts? Still starts in the middle. Cosine doesn't. Cosine's going to start at the top or bottom because of it being 1. If I flip it, it'll be at -1. If I don't flip it, it's at 1. If I flip it again, it's back at -1. Okay, so cosine will always start top and bottom, sine always starts in the middle. Now, here's all you do. You plug in the next value. What's pi over 2? What's sine of pi over 2? By the way, this is going to go up to -1 and 1. It's a unit circle, that's as far as it goes. The biggest radius you got is 1. You can't get a bigger value than 1. So what? Sine of 0 is 0. What's sine of pi over 2? 1. What's sine of pi? 0. Back to 0. You would think it repeats. Sweet, it's repeating. No, because then you get 3 pi over 2 and it does what? It goes to all these negative numbers that we don't like. And then back to 2 pi, it's what? There. Now, this is not going to take rocket surgery, okay? You ready? All right? Middle, bottom, middle, top, middle. Let me read it again. Middle, bottom, middle, top, middle. Predict the next one. If it follows the same pattern, it better be what? Bottom. Back to the middle, back to the top, back to the middle. Here's the cool thing. Once you get 2 points down, don't you already know the pattern for sine now? You only need 2 points, and then the pattern just follows every time. It's the same pattern every time. Sine and cosine, the pattern never changes. There it is. There's first sine graphs, and they are not V's. If you put V's, I will count it wrong. They need to be curvy. A couple other things I want to share about sine, and then we'll go to cosine. Everybody got it? Practice drawing it. All right. The other thing you got to write down is domain and range. No, because we're only going to graph 2 periods, so we're going to stop it. It does go on forever. Can you keep going rotations on the unit circle? I can go to 2 pi, I can go to 4 pi, I can go to 6 pi, I can go to 8 pi, I can go to 10 pi, I can go to 22 pi, I can go to 50 pi, I can go to 100 pi. You can keep going as many rotations as you want, so it does go on forever. Which brings up the domain. Since it does go on forever, have I ever told you you can't take the sign of a negative? No. We got sine of negative numbers over here. Have I ever told you you can't do the sine of 0? No, sine of 0 is what? Have I ever told you you can't do the sine of positives? Therefore, what's the domain? It is all numbers. It will go on forever. Range. Now, that's based on how you want to write it. Did you know sine and cosine, the largest value for sine is what? And the smallest value for sine is? And the same is true for cosine. So the way we can write this is -1 to 1 with brackets. What do brackets mean? Everything in between with the endpoints included. So this is like -1 less than or equal to y less than or equal to 1. Now you can write either way. I'm going with that because it's faster. If it's parentheses, would you include the endpoints? Parentheses don't include the endpoints. Brackets, you include the endpoints. So it does hit 1, it hits -1. Another thing I want you to point out here. Sine, odd or even. See if you paid attention last week. Odd or even. This would be a big detail you had to pay attention to. I went over it. Spent a whole 30 minutes on it one day. Odd. What does odd mean? He's right. Huh?
If it's negative, it's still positive.
It was an identity we did. Sine of -x equals negative sine x. This is like the disco curve. It's like the lying down disco curve, and it's like the boomerangs. It's symmetric about something. It is odd. Come on, we wrote this identity down. Thank you. Symmetric about the origin. Everybody look at it. Symmetric about the origin means you can flip it over the x and y, and you're going to get right back to the same thing. Symmetric to origin. Everybody look at it. Flip it over the x mentally. Then flip it over the y. If I flip over the x, this hump goes down, this hump goes up, then I flip it over the y, it matches right back up. So when you flip over both, it's going to be right back to the beginning. That's why this odd function identity is so awesome. Oh, yes, it is. Because when I have a negative by x, that's going to screw up my phase shift. It's going to screw up how I shift things. But what you can do is you can just take the negative and bring it where? Out front. Because flipping over the x is the same thing as flipping over the what? Y. You better get that. For example, if I had an equation that looked like this when we get to graphing, and I have sine of negative x plus pi, I can bring that negative out front after I do what first? See if you get this right. Last hour did. Yeah, I did. Not distribute it, but factor that negative out so I know the correct what? Phase shift. Now I know it goes pi to the what? It's going to go right pi. Now what can I do with this negative according to this identity? You can just put it out front. And a lot of people like it out front better. They like dealing with the negative. They like dealing with just flipping over the x. Okay? Going to be really handy, I'm telling you. Especially if I see negative in there. That's about it. I know that's sine. That's a lot. Let's do cosine real quick. Cosine's going to go way faster. You ready? Here we go. Cosine way faster. I am teaching so stinking hard. Just as hard as last hour. Not harder. And I started 3 minutes later in that class. Even after, because we sat and talked for 5 minutes. And I still can't get as far. Just the bigger the class. It's got to be it. All right, y equals cosine x. We're going to run through this fast. What's amplitude? Come on. 1. What's period? 2 pi divided by 1, which is what? 2 pi. Is there amplitude? Is there a phase shift? Vertical shift? All right, we're going to predict the domain and range without even knowing the graph. Domain, you should get. All real numbers. Domain, range. Domain for cosine and sine is all real numbers. Now, range, we should be able to get to. Negative 1 to 1 should be the same, right? Unless I vertically shift it. Then I can start changing. All right, let's practice this. We can go through this fast, okay? 1 period. Go down 2 pi. What's half of 2 pi, everybody? Pi. Since you know this one, you can just go ahead and put your 4 marks down if you want. You get to pi over 2, which is your count. So we're counting by pi over 2s. It's 3 pi over 2. Now I can come over here, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. You got to get to one, sketching one. Okay, where does cosine start? Cosine does not start at 0. Cosine starts at 1, which is at the top. It's at the top of the amplitude. Now the amplitude's kind of key. I don't know if you've realized that, because the amplitude is how far up and down you go from the middle. So the amplitude's 1, so if I'm at the top, I'm just going to go down 1 to get to the middle, down 1 to get to the bottom. Do you already know the pattern? It's the same pattern as cosine. I'm at the top, so where am I going to go now? There's only one place to go. Middle, then where? Bottom, then where? Middle, then where? Top, middle, bottom, middle, top. You'll see how fast you'll get at this. All right, now, watch this. People struggle drawing cosine. I don't know why, but they do. Here's what I want you to see. It is like a roller coaster. So come off the top like a roller coaster. Otherwise, you'll start getting V's. You got to pretend like, okay, I'm at the top of the roller coaster. How would I slope off the top of the roller coaster? It's a steady slope. All right, cosine, what kind of function, even or odd? What is it? Odd symmetric to the origin. Does this look symmetric to the origin? What does it look symmetric to? Y-axis. It's even. Even is symmetric to the y-axis. Now, this one's cool. This one is really useful. I taught you with the even function identity, cosine of negative x. Who remembers? What does cosine of negative x really equal? Who remembers it? It's on your identity sheet. What? Yes, you can just ditch the negative. That is so useful. That's like magic, man. That's like sweet. You know why? Look at when you flip it. Does anything happen when you flip over the y? It's already identical. That's why you can drop the negative. So this is symmetric to the what? I don't know if I have time to go down this alley, but I'm going to do it real quick. I got time. I can just make this quick. One more thing. How many of you know how closely cosine looks to sine? I mean, like, really know. You, like, really know how close sine is to cosine. In fact, you can tell me how close.
Is it just like a shift?
How far?
Right over 2.
Right what?
Pi over 2.
Okay, yep. Right 90, right pi over 2. Here's the deal. I actually taught you an identity. It was like 2 weeks ago when I was sick. I got one more I got to do, so y'all just got to hold tight. I'll make it up to you tomorrow. Just make me make it up to you. All right, cosine of 20 degrees was equal to sine of what? What? Which is what? I taught you an identity 2 weeks ago. It said this. It said cosine of theta. Let's do sine. It said sine of theta was equal to cosine of theta minus 90, or pi over 2. Phase shift pi over 2. Now, you look at this, you're like, okay, well, that makes sense. So if I shift cosine right 90, right? If I shift it right, oops, sorry, it's not 9 pi minus 90. It's supposed to be this. It's supposed to be 90 minus theta. Now, that's not the correct shift. See, some of you are like, well, how does it shift right? That's left 90 with a flip. Let's look at it. Cosine. If I take it left 90, so take this point, left 90, it's at 0 now. But then if I move this over, it's going down first. That's where the flip comes in. Now, I think it means the same thing as right 90. Let me show you how. This will come in handy. Watch this. Cosine, it's really negative theta plus 90. Does everybody see the left 90? Does everybody see the flip? If I go left 90 and flip, will it be sine? If I take this part right here, if I take it left 90 and flip it, will it be sine? Absolutely. I think it's the same thing Billy said. Here's why. If I factor out the negative, you get cosine of a negative theta minus 90. What did I just say you can do with negative? You can ditch it. It's really a left, right. And they do. Now, we don't use this a lot, but now you can see the connection between sine and cosine and why 2 weeks ago that worked. Okay? Yeah, I got 3 minutes? I got time for one. I wanted to do 2 more things, but I'm just going to have to do it fast. Here we go. 2 sine. Here we go. 3x plus 1. Here we go. Very quickly. I'll let you go 3 minutes early to lunch tomorrow. Does that sound good?
Yeah.
So tomorrow you get it 28 after. I'm going to let you go. All right, amplitude. It is not 1 anymore. What is it? 2. Does everybody see that? It's the coefficient of sine, and it's absolute value, so you don't need to worry about if it's negative or positive. The negative's just going to mean it what? The negative's just going to mean it what? What will a negative out front do to it? If this was negative, let's do it with negative 2. What is a negative going to do to it? Flip the graph. Very good. It's going to flip the graph over the x-axis. So we'll do it with a negative, just so you can see. Period. What's the period? It is not 2 pi. It is 2 pi divided by b, and b in this problem is 3, so the period is 2 pi over 3. Welcome to your first interesting period. Besides the fact that it's my class. Okay? Phase shift. Phase shift. Yes or no? You're so crazy.
Yeah,
Plus 1's outside the parentheses. So what's that plus 1, a phase shift or a vertical shift? It's vertical, so there's no phase shift. You put none. That is a point on my test, by the way. Vertical shift, what is it? Up 1. All right, I can do the domain and range. Let's see if you guys can. Domain, what's the domain going to be? Boom, come on. All real numbers. I think you can do the range. Think about it. Sine the middle. The amplitude's 2. So you know you're going to go up 2 from the middle and down 2 from the middle. You got that? So now it's like, instead of negative 1 to 1, what is it? Negative 2 to 2. But then what happens to the graph? Shifts up 1, so what is it? There you go, negative 1 to 3, and you didn't even have to graph it. All right, let's graph it real quick, and then you guys can go to lunch. All right, here we go. And I'll have your assignment out on Moodle in about 20 minutes, because I got it finally sent. All right, I told you go 1 period. What is the period? 2 pi over 3. Now let me go ahead and make a comment tonight. If you shift left and right, if you shift to the right, you better leave some more room to the right here to do some shifting. If you shift to the left, you better leave some room here. And tonight it's probably going to go a little rough, but that's okay. What's half of 2 pi over 3? What's half of 2 pi over 3? Come on, you can do it. Divide it by 2. What's half of 2 pi over 3?
Pi over 3.
Very good, pi over 3. Now this is the key. Half of pi over 3. Just multiply the denominator by 2. Just keep multiplying the denominator by 2. Pi over 6. That is your what? That's your count. That's what I'm counting by. So 1 pi over 6. This is 2 pi over 6. What's the next one? 3 pi over 6, which is what?
Pi over 2.
Pi over 2. That's how you know. All right? I can negate it. Negative pi over 6, negative pi over 3, negative pi over 2, and then negative 2 pi over 3. Ready? Does it shift up or down? Does it? Shifts what? All right, I like doing this. I'll put a dashed line up one because when you shift up or down, you're moving the middle. Hold on, I'm almost done. We're almost done. You're moving the middle. You are moving the middle. So the new middle is not at x-axis anymore, it's at 1. I love doing that because it helps me remember the middle's there. What do we do now? Where did sine start? Usually starts in the middle. Now it flipped. So does it go up or down first? This negative makes it go up first or down first? Here's my starting point. It goes down first. How far down does it go? It goes down 2. So go 1, 2. So it'll go 1, 2. So it's down 2. It's going to go up 2. So here we go. Ready? Middle, bottom. Where's the next point? Where's the next point? Middle. Where's the next one? Up 2. Back down to the what? Middle. All right. Go to your starting point. If I go back, it's going to go up 2. Back to the middle, down 2, back to the middle, and then you sketch your graph. I only got one example. I'll make a video with one more example so you can see one with a phase shift, and I'll send it to you, and then you'll have your homework. You're only going to graph 8 of them tonight. Most of them you're just going to write amplitude, period, phase shift, vertical shift, and make sure you get the hang of that. Okay? Thank you for giving me an extra time. I'll give you extra time tomorrow.